Hello, Bernard. Can you hear me?
Hello, I can hear you.
Yes. So, am I pronouncing your name correctly?
Yes, Bernard, correct.
Bernard. Okay. So, how old are you, Bernard?
Around 20 something.
20 something. Okay. So, when do you plan to go for college or for university?
Uh, Next year.
Next year. So,
Yeah.
you will go, I mean, you're going to study something that similar to what to the link that you shared with me. Or you
Yes,
okay.
similar. It's similar.
Okay. So, you did not select them I mean randomly, right?
No, 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 no. I sent the one is most equivalent to my university course.
Oh, okay, that's good. So, okay, let me start here. So, typically every class, not every class, but every new session with a new student, I need to go through a few things and that by time I discovered that is actually beneficial for the students, and many students does not really know about it. But I will cut it short. You are 20 years old. I believe certain things might not be really meaningful to you. So let me go through just only a few important things that will really help you. Um, First of all, did you ever use a book index? Can you see my screen?
Yes, I can hit. I can see your screen.
Okay, so did you ever see a book index?
Yes,
What do we use a book index for?
to it's like a dictionary to find the words. Is it?
Okay, so we if we would like to search for a book, to search for certain words in a book. So we look at the index. We don't go through all the pages because it's a tedious work to, if we would like to search for a single keyword. So it doesn't make sense that we have to go through all the book. We just can go through the index and see if this word is mentioned in the book and at what page. So did you ever know that in our brain also there is an index?
Not sure of that.
Okay, so in our brain, there is two pieces uh, of a kind of memory index. We call those hippocampus. But if maybe you will ask yourself, why do I mean you are a person who come to study programming? Why do you need to really understand or know about the hippocampus or even the memory index? Well, actually, that got a few reasons, and I would say um, first of all, we should know that these two pieces, we call them hippocampus. Actually, these two pieces organize or orchestrate organizing the information in your permanent memory. And that is actually important, even if you are 25 years old or 30 years old. Um, what I want to say here, the most important thing that you can relate to this hippocampus thing is that every 15 minutes of studying, you actually need to take 1 or 2 minutes of silence because this hippocampus actually do a great job in organizing and storing information for long-term storage. If this hippocampus does not really do its job well, you study something, but it will not stick in your long-term memory. So that's not good. It means that your effort is going to be wasted. So teachers who know about this information. So whenever they teach the students, they every 15 minutes they will take 1 or 2 minutes of silence. They clean the board. They check their syllabus. The result is that they will just keep silent in 1 or 2 minutes. Why? Because they want to give the hippocampus chance to actually empty the information that they already learn from your working memory. So how many memories you have? You actually have two kind of memories. Some one called a working memory and another one spread across the whole skull in a very thin layer like that. And we call that a permanent memory. So this working memory and the permanent memory, there is no connection between them. So we need the middleman to do the job of copying the information from your working memory into your permanent memory. So who does this job? It's called the hippocampus. The hippocampus have a capacity. It gets saturated with information every 10 to 15 minutes. So if it is saturated with information, it means that whenever you keep continuing giving information to it, the information will be wasted and it will not be stored in the permanent memory. Can you please let me understand if you catch anything from what I said?
Yeah, I understand what you mean.
Okay, are you able to tell me what you understood?
So there's two kind of memory. One is working memory, and one is like something key memory. And we need hippocampus to link working memory and the P memory. And for every 15 to 10 minutes of class, we need 1 to 2 minutes of silence in order for us to fully utilize the hippocampus and remember the things. Is it?
Okay, yes, correct. Yes, correct. Good, that's good. So I have to frequently ask you about your understanding. That give me an indication, not only if you are good or bad, mostly no, because I'm not your examiner here, but I need to really understand if I need to slow down, if I need to go faster. Definitely, if you are bored, it doesn't make sense to continue on the same thing. So I need to frequently ask you and I need to hear from you. So yeah, let us move forward. Did you ever see this kind of images before?
No.
Can you imagine this is an image for what?
I think the blue one is hippocampus, is it?
No, not really. Actually, this is how the information is actually linked in your brain. So here, this image give us an indication that there is a lot of connection between the information that you learned. This is when you newly learn new information. So when you are studying something new, the information are not fully linked together. Okay, so I would say that this to transform the brain from this form to this is called, the process itself is called memory consolidation. But again, why you need to know about that? So you just need to know that memory consolidation happen when you are sleeping. So 8 hours, 6 to 8 hours of sleeping is very, very important every day. This consolidation does not happen only in one night. It takes a few weeks, sometimes months, it depends on the person, to do this consolidation. So that is the one important thing that we need to know. Other than that, you don't really need to remember anything about the connection between information in your brain. So one more thing, you are going to study computer science, and you will think that everything you need to read from now on is only about computer science. But actually, the research says something different. Everything that you give to your brain, if it is a beneficial information, like even if you're reading about physics, even if you're reading about mathematics or politics, for example, just normal books that you read, general knowledge that you give to your brain, actually all this benefit your brain. Benefit it in a way that it improve your brain ability to solve problems. So your ability also to find new ways to solve problems, or the ability to do a good brainstorming improves a lot when you actually give your brain diverse information, which means that yes, you would like to be a computer scientist. Okay, we understand that, but don't limit yourself only to the knowledge of computing. This does not mean that you watch YouTube videos or TikTok videos, just entertainment one, because that will not add to your brain. That will actually consume your brain ability. I'm talking about reading beneficial information. Any kind of beneficial books will definitely add to your abilities. So it's all going to be connected inside your brain. Did I make myself clear?
Yes.
Okay. So the last thing that I'm going to share with you, and this is very, very important in programming. Your brain function in two, or operates in two modes. One is called focus mode, and we all know about it. And another mode is called diffuse thinking mode. So when you are listening to me at the moment, your brain is actually functioning in the focus mode. And this focus mode have certain abilities, which is good for us, but it is still lacking a lot. So, okay, if you study something and you really cannot understand it, so you have to go out of this focused thinking mode. You have to switch to another mode. And I would tell you, a lot of people that I teach, even working people, does not really know about this diffuse thinking mode. And in programming, you're going to face a lot of challenges. I'm not discouraging you, but this is a reality. I mean, I was a programmer before I became a teacher. I have been lecturing from 10 to 15 years ago, even when I was still a programmer. So I know very well that every programmer will face some challenges. And if you follow a good technique, then you will save your nerves and you will not burn your nerves and you will be able to solve problem fast. This is just a process that you need to tackle and you know how to handle. And that will also happen during your study. So how we can actually trigger our mode, our brain, to work in the diffuse thinking mode. The diffuse thinking mode needs you to be very relaxed, which means that it can be triggered when you are sitting in front of the sea, when you are walking in a jungle, when you are maybe just hiking or thinking about nothing. If you close your eye and just think about nothing, close your eye, relax, think about nothing, you are actually triggering the diffuse thinking mode. So if you ever get stuck in solving a problem for more than 30 minutes, then it is time to trigger your diffuse thinking mode. Go make a cup of tea, cup of coffee, and just go and drink it maybe in a balcony, or go see some nice views. Just make sure that you don't busy your brain with watching TV, or because that does not trigger the diffuse thinking mode. Your brain need to think about nothing. If you are thinking about nothing, this trigger the diffuse thinking mode. Please tell me, what did you understand so far?
So there's two types of thinking. One is focus and one is diffuse. So focused thinking is like when you are studying or you are focusing on doing something. So if you are not able to understand at the moment, you need to switch to diffuse thinking mode. So diffuse thinking mode can be like like in the jungle or in front of a sea and
Okay.
taking a coffee or going to a balcony.
Just be relaxed, think about nothing.
Yeah, and be thinking about nothing.
Okay. So is that, will you give up from the first time? So, okay, let me assume you already facing a problem. I give you a question or an exercise that you try to solve, but you cannot really solve it from the first time. So, okay, you tried to trigger the diffuse thinking mode. You go back to try to solve the problem. You still cannot do it. You need to keep trying to trigger the diffuse thinking mode a few times. So it means that, okay, we tried something, 30 minutes, we cannot fix the problem. We take 10 to 15 minutes of triggering the diffuse thinking mode, and then we go back to try to solve the exercise. If it doesn't work for another 30 minutes of trying to solve the exercise, we trigger again the diffuse thinking mode. We can do that a few times. For me, it worked from the first or second time at max. So I spend hours, long hours, trying to solve programming problems, but that was not the correct way, because I would have saved these hours if I follow the correct way of using the diffuse thinking mode. But definitely this kind of thinking or even modes is not taught in schools. It is something new that scientists actually managed to find. Okay, so is that clear so far?
Yes.
Okay, so let me move ahead to try to okay, so we actually need you to register on this website. This will act as I mean, that will do the job at the start. This website will allow you to write Python in or any programming language that you might actually encounter. So that is free for with certain limitations. So at certain times, once we start to write heavy programs, or even we write a lot of programs, the free tier will actually I mean, it will get like saturated, or you reach the limit, and then they will ask you to actually pay. So until we reach that level, so I think you would have actually passed some good amount of knowledge that I'm able to tell you how to really install any other software on your PC yourself. Okay, so there is a free tools that you are able to install on your PC, but the problem here that to be able to share the output, either me or you, or even share the code, it is tedious if we would like to do it on your computer. This website allow you to write a code that you're able to share with me, that you're able to share with everybody, and you are able to write different languages, and you are able to write the code and see the output on the same page without a lot of switching between screens. Because in the Replit, in the Zoom, if you would like to share a screen, you're not able to share two screens at the same time. So typically, if you install a Python software on your PC, so that will require from you to, if you would like to share an output with me, that you switch between many screens. So that will consume a bit of time. So we will try to use this Replit at the start. And then once we succeed in that, I will move on to tell you what is the next step. Is that okay for you?
Okay, can.
Okay, so that will only require email from you, nothing more than an email. Hopefully they don't change that. And I would say, let me move to just try to understand from you. So you told me that you are totally new to computer, right? You didn't study any computer before.
No.
Okay, so do you know what is this?
My guess, I think it's transistor or something like that.
No, so this is a hard disk, a kind of hard disk that's called SSD. So, okay, let me just explain things to you. The point, if you study outside Malaysia, so most of my students whom I teach outside Malaysia, definitely, and even some of my students who study inside Malaysia. So if they study something called IGCSE, did you ever hear about IGCSE?
Yes, I took IGCSE.
You took IGCSE?
Yes.
Oh, okay. So, but you didn't take computer science or level,
Yeah.
or so, wow. So you didn't take 0478. You didn't take this.
No.
Oh, okay. That's interesting. Did you take it in a private school or Mara?
IGCSE, I took it in my international school.
Okay, that's quite new to me. Okay, because yeah, I teach many students IGCSE. I mean, they take computer science. I understand that not all of the schools choose to have a knowledge about or study that subject, but okay, never mind. So what I want to say that when you go outside, you will find that most of the Europeans and Americans, they study computer science from early age, 7 to 8 years. They start from 7 to 8 years. So certain things I need to pass to you, not only Python, because you will find yourself a bit behind if I don't pass you that. Definitely, maybe your interest maybe not in to take everything that the people in the IJCC or even the people at 15 years old take, but I will try my best to pass you information. At least when you hit certain topics in Python, you need to have certain backgrounds. So I will try to pass you that in between the lines. Definitely in the university course, they assume no programming knowledge, yes, but they assume some computer background. Okay, so they will not be able to give you all the computer background from a single course. Okay, so I will try my best to just pass you that information in between our classes. Is that okay for you?
Okay.
Okay, so the SSD is actually hard disk, and this is a new type of hard disk that is very light in weight. It does not have any mechanical parts. It have a very high transfer rate, which means that you're able to transfer information to the hard disk and outside the hard disk in a very fast speed. Do you know what I mean hard disk? You don't have to be shy. I mean, you need to be open so that I know what to teach you. Okay?
I'm not sure, but I'm thinking, is it hardware?
Yes, it's hardware inside your computer or even your laptop. This is very popular inside new laptops because this is very light in weight. And as I said, it does not have any mechanical parts. Let me try to share with you here. Hopefully I have, yeah. So if you look at this is the old type of hard disk. This is how it looks from inside. So there is the mechanical parts that rotates. There is a motor here, and there is another kind of magnetic motors that move the reading head this way and this way. So everything that you store on your computer actually is stored in this device. And this device is quite heavy. When we have old laptops, like maybe 10, 12 years ago, they have this kind of hard disk inside. That's why the laptop is quite heavy. And nowadays, they managed to make the laptops lightweight. Why? Because they replace these mechanical parts with a new type of hard disk that we call it SSD. So this SSD start with a bigger size, like what we saw here, and in laptops it becomes smaller and much lighter in weight. So far, did you understand anything from what I said? And if you understand, please let me know. I mean, don't be shy to say anything wrong. It doesn't matter. I mean, I just need to know to what level you are able to accept and understand information.
Okay. So you want me to explain?
Yes, what you understood so far about the SSD and hard disk.
So SSD is the newest hardware compared to HDD, is it?
Yes, correct. Correct. Yes.
And I mean the rate to transfer information to the SSD is very fast and it's very lightweight, and it's usually in our newest laptop compared to HDD, which is very heavy and it can only move like left to right direction. And
okay,
yeah,
that's great. Yes, that is great. That's great. That's great. So okay, do you know, I mean, I'm not sure if 10 years ago you was having a laptop or even a computer or not, but if you open a new PC or even a new laptop, you will find that they open the Windows very fast, or they load the Windows software very fast. So I think now you're dealing with a Windows laptop, right?
Yes.
So the Windows laptop open very fast in new computers or new laptops. Why? Because they are equipped with SSD. Last time, it can take up to 3 or 4 minutes just to open the Windows. Why? Because we was using slow hard disk, which is the place where we store all our permanent storage. The permanent storage means everything that we would like to keep after we disconnect electricity from our computer. So all the videos, all the pictures, all the information that you store on the computer itself is actually stored on a hard disk like that. Okay. So as we said, we have two types: the old style hard disk and the new one. Okay. So if you use an old one, it might take some time to open the Windows itself, to open videos, to open files, to open programs, even on your laptop. But with the new SSD, things are actually moving fast. So I will not speak more than that, but one more thing to note: if you look here, the distance between the reading head and this platter, this thing that rotates, where we actually store the information, is very, very small, that we even cannot see with our eyes. Let me just share with you how it looks like. So if I put a human hair between the reading head, this is the reading head and this is the platter. If I put a human hair, it will appear so big compared to the distance between the head and the platter. So what does this mean? It means that if your hard disk that have mechanical parts, if it fall on the floor, it is gone. It cannot be used anymore. Most probably it is damaged. But with a new hard disk, the SSD, you actually heat it, it's okay. It still will work again. Definitely there is some heats that will break certain things inside, some electronics inside the SSD. But a normal heat will not cause the damage that will happen to a hard disk that have mechanical parts like that. Did I manage to make myself clear so far?
Yes.
Okay, that's good. So are you able to guess what you are seeing on the screen? Just guess.
From the topic, I think it's RAM, is it?
Yes, exactly. Yes. Okay. So this was the RAM when they created or they invented the computer in the 1960s. So it was so big and so full of mechanical parts. But now this is how the RAM looks like in a PC. And that is how the RAM looks like in a laptop. So if you notice, the laptop RAM is more compact compared to the one in the PC. And definitely it is higher in the price. So what is the RAM actually? So the RAM, actually, it is a piece of hardware that we have it in computers, either laptop or PC, it doesn't matter. And it decides how fast your computer actually are going to operate. The more RAM that you have on your PC or laptop, the more things that you are able to open at the same time without affecting the speed of your computer. So now you are opening Zoom, and maybe you are also transferring some information from the internet, and maybe also you are opening your Replit or even a web browser. And maybe you're opening many things, many files or many programs at the same time. You are only able to do that when you have good amount of RAM inside your computer. So what is the difference between the RAM? First of all, what did you understand so far about the RAM?
So it allows you to open multiple tabs at the same time without compromising speed of the computer.
Okay, excellent. So, okay, now let me go to the next. I will explain about this slide that I skipped, but let me try to understand. Do you know what a CPU is?
CPU, is it the brain of the computer?
Excellent, yes. So yes, the CPU is the brain of the computer. So the CPU operates very fast to the extent that we are able to execute maybe up to 4 billion instructions per second. Actually, even more than that. 4 billion instructions per second. So the CPU operates very fast. So let us go back. I mean, instruction, it is what we're going to study in Python. Every line that we're going to learn in Python is an instruction. So we need to have the basic of that. Actually, the students actually study more deeply than what I'm teaching you. But I mean, as a start, I would just give you little bit hints here and there before we start to dive into Python. Do you understand what is that? I mean, even if you look at the header here, are you able to guess what is this? Did you ever see that in your computer?
Oh, yes. I think it links all the hardware together.
Excellent. Yes, yes. So this is the motherboard, and we put typically we put the processor under this metal part, and we also able to put the RAM here, and we have connectors to connect the hard disk. So this is like, yes, it is able to connect all the hardware together. Yes, correct. So let us go back. As we said, that the CPU operate in a very high speed, and the SSD speed cannot be compared to the RAM speed. The RAM operate at a very high speed. That's why it is expensive, and maybe we are able to get something like, I mean, in new computers, maybe you can get something like 6 gigabytes of RAM, which is not bad at all. And the size of your hard disk might be possibly 500 gigabytes, sometimes more, sometimes 1 tera in new laptops. So if you compare 500 to 16, you will notice that there is a big difference. So this is the SSD, which is the hard disk, which is the permanent storage. So this is our permanent storage. This is our RAM. What's the difference between the permanent storage and the RAM? The RAM, it loses its content once you power off. The hard disk are able to maintain its content even if you power off. So the Windows or even Mac OS on your Apple laptop you're able to maintain all the videos, all the pictures, all the operating system, because you store it on the hard disk, which is a permanent storage. And this need to be big because you have a lot of things to store. So, and the RAM, we need it. Why? Because the hard disk, even though it is a little bit fast, which is, I mean, I'm talking about the SSD, but it is not as fast as the RAM. The RAM is much, much faster than the hard disk. So, and the CPU operate at a very high speed. This is the CPU. The CPU are not able to deal directly with SSD because it's very slow. So everything we need to open, either a video, a picture, a program like the Zoom web browser, we need to transfer it from the SSD to the RAM first. And then the CPU are able to get whatever stored in the RAM and do some processing on it. Of course, I'm not able to explain the CPU processing in details because that is whole chapters that certain people in the IGCSE take. But if we feel that there is a need for that in the future, I will go through the detailed step of how actually the CPU execute every instruction from the memory. Okay. So at the moment, are you able? Did you catch what I say by at least 60 to 70%?
Oh, yes.
So are you able to give me an idea about what you understood so far?
Yeah, so SSD cannot directly link to CPU because I think either of it is too slow and one of it too fast. So we need RAM to do the middleman so that the information can move from SSD to RAM and RAM to CPU.
Yes, correct. Yes. So the response of the CPU operate at a very, very high speed. And the technology improvement in the CPU is great. So we keep increasing the speed and the processing ability of the CPU. But the other hardware, we are not able to have the same technological improvement. So the transfer, even the transfer between of information from the RAM itself to the CPU is still slow. And there is ways to improve that. And I mean, there is techniques and ways to improve that, but maybe we will not talk about it now. So far, I will stop here, this portion, and then I will move you from the hardware to introduce some part of the, oh, sorry, I forgot. I need to explain that to you because that is very important in understanding programming. Give me a second, please. I need to delete here. So I explained about the RAM, but I did not explain about one important thing here. The RAM, it is divided into places for storage, and every place have an address. So are you okay? Let me try to relate that to real world. If we have a taman, and this taman have maybe 200 houses. So this is a house, and inside this taman, we have, as we said, we have almost 200 houses. Every house have a number. Am I right? Did you ever see a house without a number?
No.
Okay, so every house must have a number. If you don't have a number for the house, people are not able to reach the house. You are not able to order things from Shopee, Lazada, or whatsoever, and receive it at the house because you don't have a house number. So we need the house number to be able to locate that house and maybe possibly reach the house, send something to the house, collect something from the house. Is that clear to you, this concept?
Yes.
Okay.
Yes.
So to do that with the RAM, we need to use the same concept. The RAM is organized into places for storage. So these places for storage, imagine it's like a house. And for every place of storage, we have an address. It is the same like the house address, but we start here from 0. So you find that this is 0, this is address 0, this is address 1, this is address 2, this is address 3. For every address, there is a place to store the information. So the CPU will say, go to the address 0 and store that information in the address 0. And then go to address 1 and store some information in address 1, and so on. Did I make myself clear? Is it clear now? How
this is the RAM, is it?
Yes, this is the RAM. Yes, this is the RAM, and this is how information in the RAM is actually it's divided into 2 parts. This is address, this is data. So information or data is stored in this place, and the address of the place is actually here. So this is how, from inside, how the RAM looks like or how it behaves. So did I make myself clear? And do you have any questions?
Yes, I don't have any question.
You don't have, right?
Don't have, yeah.
Okay, okay. So that is, I will stop here. Give me a second. I need to switch to another slide to act as an introduction. So Bernard, again, if you notice here, I mean, this is basically the IGCSE syllabus for computer science. Okay, it acts as a very, very strong and very, how to say, solid introduction. So I will just steal slides here and there because that slides definitely is not in the syllabus that you passed to me. Just to how to say, to simplify it to your brain, since this is very new. So just you need to be aware that you will have some resistance from your brain because this is totally new and you are slightly older than it should be. This does not, I mean, I personally learned that at your age. I did not learn computer science earlier because at my time, there was not computer science at earlier age. Okay, so this should not discourage you. So I mean, you need to put an effort. Me and you should know that you need to put an effort. And you should not be surprised that you find some resistance or find that this information is heavy. Yes, it will be heavy because this is the first time you learn it. Others might learn it at earlier age, but this should not discourage you. Okay, is that clear so far?
Yes.
Okay, that's good. So let me introduce you to a term that is called algorithm. So an algorithm, we have it in computer science, and we also use the term algorithm even in real life. And I will show you how. So what is an algorithm? It is a step-by-step procedure or a set of rules designed to perform a specific task or solve a problem. So this step-by-step, we will use it in programming. So you have a problem in the programming. So a programming, you are writing some codes to solve a problem. You would like to get an average of certain numbers. You would like to make a computer program to actually help calculate the profit and the loss of a supermarket or a store, a big store. So this is the kind of problem we're going to solve using programming. Okay. So, but at the end of the day, we can break that down into small steps. So we need to specify the small steps that we make to make a big program even possible. Okay. So the algorithm is that everything that we're going to organize in a step-by-step procedure in order for us to solve any problem. Is that so far clear?
Yes.
Okay. Did you buy anything from IKEA before?
Yes.
Did you see the detailed instructions given to you in an IKEA manual?
Oh, yes.
So these instructions, we are able to say it is an algorithm. Everybody who follow that instructions are able to have an assembled table or even an assembled chair or even any kind of assembled furniture that comes from IKEA. So they designed the algorithm in a way that everybody who follows that will reach the final output that they actually want. So is that, are we at the same page? Did you understand what I mean?
Yes.
Okay. If you look here, you will find that we are actually talking about an algorithm here on the left-hand side that if we follow it, we will be able to have a pancake or an apple pie. Okay. So how are we going to start? So we are able to tell that we are able to mark the algorithm by start and stop. And we say that we're going to put 100 grams of flour in a bowl, and we will crack 2 eggs into a bowl. So this is a step 1. Then you move to a step 2. And then the step 3 is to add 300 milliliters of milk. And then we do some kind of process, which is we need to mix the ingredients together. And then we need to check for a condition. Is it the ingredients become smooth or not? If it is not smooth, we need to keep mixing them together, like this thing is doing here. So if it is now become very smooth, so it means that the ingredients already mix very well together. So we will go to the branch that called yes. So at the end, what is important for us is not to know the steps of how to make an apple pie or this pancake. The thing is, the thing that this thing that you're seeing in the screen, this rounded rectangles and parallelograms, and even the rectangles here, this is something called flow chart. And that is one of the methods to represent an algorithm before you start to write a code. So when we have a problem in Python that we want to solve it, typically, if the problem is big, we need to design an algorithm first. To design and represent an algorithm, there is tools that we are able to use. One of the tools is called flowchart. So this is the flowchart. I mean, at the moment, I will still make you focus on Python. So I will not explain flowchart in details unless we see a need for that in the coming classes. But I just need to introduce you to that because you are able to hear that in many of the computer science courses. Okay, so flowchart should be something meaningful to you when you hear that word. So this should come to your brain. This kind of instructions and step-by-step procedure should come to your brain. So you are, I mean, if you study flowchart, you will be able to see that if you design something like that, you are able to translate it into Python code very easy. Okay, so if we're having a simple problem, we don't need to use a flowchart. We are able to rush directly to write a program in Python. But if the program that we need to write is big, then we must write a flowchart or even draw our algorithm on paper first before we start to write any coding. So far, is that clear?
Oh, yes.
Okay. So did you understand what is a flowchart?
Yes, it's a set of step-by-step procedure in order to like perform a specific task or solve a problem.
Yes, correct. That is excellent. Yes, that's great. Yeah. So as I said, this is heavy as a start. So don't be discouraged. Now let me move a bit to the slides. So, okay, I have a comment on the slides that you shared with me. These slides, I would say that specifically in your case, might be maybe slightly harder to digest. I would be reluctant to use it, but since you decide that you want to go through it, so I will. I mean, if you give me the choice, I will introduce you a bit with the IGCSE slides for Python before I bring you here. Maybe 1 or 2 classes to ease and simplify things to you, and then I bring you here. But if
actually, sorry.
Yeah.
Sorry to disturb. So actually, I have the university code module, but I do not know what that module contains. So I just search like whatever is similar.
Okay.
So I'm not sure whether is it the same at all, you know. Because I just want to study before the university starts so that I can be more prepared. And
yes, this is a good step, because if you didn't study computer science, you will be hit hard by that. So I already taught not only university students but also a pre-university students who's preparing to travel to Australia for studying. But that is for elite people in some kind of politicians here. But anyhow, so what I want to say, it doesn't matter. It's all leading to the same direction. So either I'm using these slides or even other slides, it is the Python is still the same. It is only the way to simplify that. I mean, we earn nothing if we get you discouraged. We would like to make it easy for you. The more we simplify it and you start to like it, that is good. We will study all the information. I mean, either in this slide or the other slides, they all handling or talking about the same Python. We are not talking about different Python. Okay, it is just the representation of the slide or the information and the organizing of it only. That what differs a lot. So anyhow, let me try to go with the slides here. And if you have other slides, maybe you can pass it to me, and then I can have a look at it. If it is easy, then the most important is easy as a start. At least the first 2 or 3 classes, things must be easier, or else you will shut down. I already experienced that before. So the first 3 or 4 classes is very important actually. We need to make you love programming, or else we will get, I mean, you'll get nowhere. Okay?
Okay.
So you can share with me what you have, and I will start with that what I have at the moment at this class, and then we can see afterwards how it goes. Okay?
Okay.
Okay. So you have to understand that nobody learn programming by looking, by eyes. It doesn't work. So you will get saturated after 10 minutes. So every class you should be prepared that you should share your screen, and every code we learn, you should start to write. When you experience things with your own hand, and then we start to experiment together, things will stick to your brain, and it will not act as a heavy load on your brain to digest after the class. Okay?
Yeah.
Okay, good. So okay. So he is explaining here why you need to learn to program. So I also don't find it so easy what he's telling here, but at the end of the day, he's saying that programming here is like a magic black box. You tell it whatever you want and give it certain rules, and it will do it for you. So this is what we said, that it is a step-by-step instructions that if we follow, we are able to solve a certain problem. So that is, in short, what he trying to say here. But maybe he is trying to say it in a little bit different way. So okay, let me this is something that is not related to Python itself. This is about the professor. This is about the logo of the course. This is about the course website. This is about the professor again, which is okay. Yeah, this is something that we actually also need to understand. So in programming, we have something called front end and something called back end. So it is exactly same. This is the kitchen where you actually prepare the meal that you would like to present. And the front end, you will see that the waiter or even the chef come in a clean, prepared plate, covered nicely, and presented to people who want to eat. Yet it looks like the father, he's the one who preparing the meal to the child. So if you look at the back end, you will find that everything is messy inside, right? But in the front end, everything is clean. So everything you see on a website, it's called the front end. Everything work under the hood on the website, it is actually the back end. So in the programming, not in Python specifically, Python is a different story. Typically programmers are able to decide which way to go. Certain programmers work at the front end, which means that they design screens, they design how the menus, how the buttons in either a program or even a website is going to work, how it looks like, how it will attract people. So that needs some creativity. So you need to be good maybe at drawing at the first place, because if you are good at drawing, it means that you have the sense of making a good design. So then I would advise you to go as a front-end programmer. The back end is a different story. So the back end, where you need to do the heavy lifting, all the heavy coding and storing of information and maybe authenticating users. So when you go to the Shopee website, you have to log into the Shopee first, right? You see
Yes.
the password and username and you enter them. After that, they allow you to enter the website, right?
Yes.
Okay, so when you enter the screen, that it appears to you where you can put the password and the username, it is designed by the front end. But to really authenticate that you are really the real person that you expected to enter to the account, all this kind of checking is done by the back end. Python acting actually as a back end. So if we would like to involve Python in a website, mostly it is acting on the back end. So you need to do the coding for Python at actually the back end. The Python does not appear to draw menus or even show screens or even show where the button should be located and what color is the button is, or no. Python is a totally different story. So far, did you understand anything? This is too early. I mean, this discussion of front end and back end is too early, since you don't really know yet what Python actually can do. But did you understand anything? Did you catch even 30 to 40% of what I said?
Yeah.
Okay, what did you understand about front end at least?
So there's two type of programmer. One is front end and back end. Front end is like the view of the website, like all the things that present on the front, like button,
Screen.
like
Yes,
like
yes, correct.
designing like the website itself. And backend is have to do with a lot of heavy coding or heavy programming.
Okay, okay,
Yeah.
that's enough. Yes, that's enough. It's no problem. Okay, so okay. So he is talking here about what is expected that you come out after you finish the course. So there is, of course, certain topic about procedure programming, or I mean, object-oriented and searching and sorting algorithm. This will doesn't make any sense to you at the moment. So I think explaining this to you in the start, I think it's actually not really. He's comparing here certain courses. I don't think that this is not correct for a person who's still learning how to actually write. So I would say that also. So why we choose Python? Python is very easy to learn. You will need to learn. I mean, it depends on university, but from my university students that I teach, some of them, or I would say 80% of them, learn Java along with Python, and some more learn C++, C and C++. So you might end up learning C and C++, or focusing only on Java. Java and C++ actually are very close, but C and C++ are much harder than Java. So you can imagine that C and C++ actually come to the whole world first, was designed first in 1970s, and Java come afterwards in the 1990s. Okay, so is that clear so far?
One question is, do we get to choose what programming language we're gonna use, or
No,
the university will specify?
That university will specify. It's yeah, they don't give you choices. No, they don't give you. It is like the person who the department of the computer science is the one that decide which direction they will take you to, and definitely certain. I mean, if you're talking about Java and C++, this is decided by the department of computer science. But certain other languages will be decided based on your choice of what you want to become at the end. You have to understand, or I can explain later about branches that you are actually can become. So you can become a web developer, you can become cybersecurity specialist. I mean, there is many branches. Every branch have its own set of languages and tools that you're going to use. So, but the basics, everybody had to learn, like C++ or Java, this is decided, and everybody had to learn it first. But except for cybersecurity specialists, normally they will not learn a lot of programming. But if you would like to become a normal programmer, like produce software for desktops or this kind of thing. So you will definitely learn Java or C++. Okay, and definitely one of the things is Python. So if you learn AI, Python is your how to say, your sister and brother and whole family. You cannot move to AI without, or even data analyst. So data analysis is actually, Python is your only friend that you're going to use. Not
So,
only, but majority, yes.
so there's only three languages: Java, C++, and Python, is it?
No, there is more languages.
Or there's more?
There is
Like, let's
more.
say you want to become like a normal software engineer, like which one is more suitable?
I mean, this is normally the introductory courses come in Python and Java, normally.
Okay.
So this is actually act as a start. There is other languages that you might need to use, but it depends on the, and I think this will, you will take it maybe third and fourth year of study, but you have to start with Java and Python. This is what I would say. So, but you look first at what syllabus you have. If you see that they use C++ instead of Java, then we have to go for that. Okay. So it depends on, I mean, we're trying to prepare you for the university, right? Every university have a different requirement.
Should I check now for my university what they use?
Yes. You are able to look and see. Yes, there is no problem. So, I mean, you want to tell me that you would like to check at the moment during the class now, you mean?
Just like 30 seconds, like 1 minute, like
Yes, no problem, no problem.
It's called computer programming language.
Yes. Yeah, this is all under the computer programming language. Yes, but there must be, I mean, there must be some details that can tell us what is this computer programming language. You would like to share a screen with me?
Oh, I'm using my phone and check.
Okay.
Oh, they say first year is Python, second year is Java, C, and MIPS assembly, and third year
Okay.
C, SQL, JavaScript, C++ functional language. So they say first year Python first.
Okay, which is not bad at all. Actually, this is great, because Python as a start will encourage you actually to love it. Java is slightly heavy, so yes, that's actually good. Then we are moving on the correct direction then. Okay, so okay, let me. Typically in the introductory class, I never teach that much, but let me just take you a few minutes. Okay, let me just do something simple with you, so that normally first class I don't really put too much. Okay, can you see my screen? This is my replet. This is what you should have in the next class. Okay? Okay, good. So this is where I'm going to write Python. And then just let me do something very simple. So I will say x equal 2. And then I will go to the second line, say y equal 3. And then third line, I will say z equal x plus y. And then fourth, I will say print z. Okay, so let us go line by line first before we, or let me run first and let me show you. So when I run, do you notice that when we say we print z, we printed 5? And if you can imagine that this 5 is a result of adding 2 plus 3. Does this make sense to you?
Yes.
Okay, that's good. So what is the first line saying? It say, go to the RAM. We know that the RAM is a place where we're going to store our instructions, where the CPU can access it. So I am telling the Python or the computer, I'm giving him an instruction, reserve a place in the memory and call it X. So he will make X. And inside the place X, store a value. Okay? So we will come here, store what? We will store 2 inside the place X. Again, we also come on the second line, it say Y equals 3, which means that Python, please go to the memory, reserve a place called Y, and store 3 inside it. So we will put 3 here, and we will code that place actually Y. And so this X and Y, 2 separate places. Here have 2, here have 3. And then on the third line, I see that I have a variable or something called Z. And inside Z, I say, get whatever stored in X and whatever stored in Y and add them together and store the result in Z. So he will see that Z is need to be having a place in the memory. So I will go in the memory like that. This is Z. I will actually store the result of the addition, which is actually 5. So I will come here, put 5. So X is a variable. A variable, it is a way for me to say that this is a place reserved in the RAM to store information. So how many variables I have? I have X, Y, and Z. Each one of those have separate piece of information that I'm able to use. So I make 2 numbers, I add the 2 numbers, and then I printed the results of the addition. So this line number 4 is saying print Z. What is Z? It means go to the RAM, fetch out the data stored in the variable Z, and print it out to the user on the screen. So I added these 2, and this result in 5, and it was stored in that, and I printed the 5 here. The 5 is actually stored in the memory. So all this information is actually stored in the memory. So when we use print, we actually try to get what is stored in the memory to see it with our own eyes, because not everything we are able to imagine. So did you understand anything? Is that hard to digest?
Oh, not really.
Okay, so let me also tell you something else here. So if I come here and then I change this to, let me close this. If I change this to 20 and I change this to 31, for example, and then I press run. Do you see the output here?
Yes.
So the output become 51. So here, this is become 20. This is become 31. If I add both, it will result in 51. Did you understand now that my program is already fixed? I already fixed my program. I just change the values of the variables, and I will definitely have a different result. Is that clear to you?
Okay.
Clear?
Yes.
By how many percent? 70, 80%?
Maybe 90%.
Okay, that's not bad at all. But you will not start to really deeply understand unless we start to write. So, but I will stop here at the moment, and then on the next class, you come prepared with, you already register on Replit, and then we start to run these exercises, okay?
I have one question.
Yes, please.
Like, do computer science have to do with a lot of memorizing, or no need?
Theoretical part might need memorizing, but understanding more than memorizing. So I would say 60 to 70% of it is understanding and practice. not memorizing. 30% only, 20 to 30% only memorizing.
Okay.
So it's not, you need to use your brain more than to practice and to write and to think rather than actually memorizing. No, not much memorizing. So far, is it clear?
Yeah, it's clear.
Okay, let me just give you this. So so from what I experienced with other students, either the pre-university or even university, you need at least two. Are we in a hurry? How many months you have before you start to go to your college or university?
There's long time, like 1 year.
Okay, so okay, because if you're in a hurry, then we have to increase more than 2 classes a week. I mean, with all my students, typically we take. I mean, I see that so far from what I see, but I can't really tell 100% until another 2 or 3 classes. From what I see, that you are okay. You don't have any problem so far from what I see. But that will appear later when we discuss things together. So I hope that everything is fine on your side. Are you good in mathematics?
Yeah, my strong subject is mathematics. I think my strongest subject is mathematics.
Okay, and you don't suffer any problems in mathematics, in doing mathematics, right?
No.
Do you have any attention deficit? Like, do you forget things very fast?
No.
No. Okay, that's a good that's a good thing, because I mean, that is a sign of a slow learner, which means that it will take longer time. So okay, now let me do this. Typically, you need at least 2 classes, and per week, and then at least I mean, normally I try 2 hours per class, and that doesn't work. The student gets saturated too much, and this is too much for you. So the maximum we go for is 1 hour and a half for every class. What we will do is, why we need 1 hour and a half? 1 hour and a half, if we're talking about theoretical side, is already too much. But the thing is, every class I must give you an exercise. And when you do the exercise, definitely we need to have a discussion about your homework and exercise. And that takes time. So if we choose to have 1 hour only per class, that will actually disrupt the amount of information that we're going to learn every class. So half an hour typically goes for discussion about what is the problem that you faced with your exercise, what is the things that you don't understand, if you really understand properly or not. So that goes for 20 to 30 minutes typically from the class, and then the remaining we go for taking something new. So like I said, my recommendation is 1 hour and a half, 2 times a week, and then we see how it goes. Okay.
I just want to ask, average, how many classes a student have per day, average? Per year, per week.
Per what again?
Per week. Like normally, average, how many students have class per week?
You're talking about my students? So I mean, yeah. So okay, well, certain students, but I mean, that was I mean, certain students, like, okay, there is 2 types of student who take more than 2 classes. One very smart student who have an A-level IGCSE computer exam, that she have a deadline. She need to learn Python in a very short period, in maybe 1 month, 3 weeks, something like that. So she took 3 classes per week. And there was another slow learner who took 4 classes per week, because again, we needed to move very, very slow. And so we needed we needed more time to cover the syllabus of the IGCSE syllabus. So he needed more time, because he need to go in his slow pace. If I explain to him like I'm explaining to you now, he will not understand. He sometimes also need different slides, so things are different. So it depends. Some people want to finish very fast. Some people I mean, it totally depends on the situation. From you, I mean, it totally depends, but I would not recommend to go to 3 classes at the moment. Let me see first your reactions, your engagement in the next 2 or 3 classes, and then we can say that, oh, do we need to really need 3 classes per week, or it is enough to have these 2? Okay.
Okay.
This is my advice, but at the end, it is your choice.
Okay. So we start with 2 classes first?
Yes. Yes, we start with 2 classes first. Okay. Okay. So any other questions before we close?
No.
Okay. So I'm going to tell you how much I need to bill you for this class. And then once we start to move on, I will deduct this. Typically, okay, let me also explain this before we close so that you have it in words so that you're not confused. Typically, any demo class is only 40 minutes. Only 40 minutes. So this is the free demo class that I give to all students. In your case, since it's slightly different, so what I would say, yes, if you continue and if you are serious, because from what I experienced, that was not nice at all. So it was like wasting a lot of time in demo classes that people keep canceling things. So what I want to say that, yes, I will deduct this 40 minutes class from other classes that you have. So it means that you have to pay less 40 minutes later, but let me see that you are serious. Okay? Okay, that's good.
So
okay.
So I pay weekly?
You can. It's your choice.
Okay.
Yes, you can pay weekly.
Right.
Yes, no problem. Okay?
Okay.
Okay. Take care. Bye-bye.
Yeah, thank you. Bye-bye.